Hello, and welcome to today's webinar, Legacy Applications in Your Company, the ROI and an Organizational Impact. My name is Erin, and on behalf of IOUG headquarters, I would like to thank you for joining us today. Today's broadcast is brought to you by our sponsor, Stromasys. Before we begin, I would like to remind the audience to please feel free to submit questions throughout the event via the question chat box of your GoToWebinar toolbar. Our speakers will leave some time at the very end of the presentation to address any questions. So now I would like to turn the call over to today's speakers. Please go ahead.
Hi everyone, my name is Sandy Levitt and I'm a senior sales engineer and I serve on the Global Alliance and Channels team. And we also have Dave who will introduce himself.
Hi, Dave Clements here. I am Head of Field Engineering in the Americas for Stromasys. And welcome, everyone.
So this is what our agenda is going to be. The first thing we're going to do is what is legacy hardware? We're going to go over the risks and costs associated with such legacy hardware. What are your options for the legacy hardware? And then I'm going to turn it over to Dave, who's going to go over 3 different case studies that we have to discuss. And then at the end, of course, we will answer any questions. So what is legacy hardware? Well, legacy hardware is, I'm sure you can all read the slides, but basically it's proprietary architectures that are no longer manufactured. And such examples are DEC alphas, PDPs, and VAXs from the old digital equipment days, HP 3000 and HP 9000, and the Sun Spark systems, the ones that were done by Sun as opposed to Oracle, such as the 4U or the 4M architectures that are out there. So let's talk about technology lifecycle. Basically, when you're talking about the life cycle of different parts of the technology, the hardware has a very, very short life cycle. Basically, as soon as some new hardware comes out, the next hardware is already almost ready to come out as well. So hardware turnover and hardware is very, very short. It's very similar to anything else, such as televisions, cars, or anything that is new technology keeps coming. The cycle is very, very short. And then you have your operating system life cycle. Back in the 1990s, proprietary Unixes, for example, were the very big operating systems. You had IBM with AIX, you had HP with HPUX, you had Sun with Solaris, and you had Digital and Compact with their True 64 Unix. Nowadays, when you're looking at what is the big OSs, it's the open source, Linux, such as Red Hat, Ubuntu, SUSE. So that's the change, but the change is usually a longer cycle. And then, of course, there's the applications. The applications have the longest life cycle because once you create an application or running an application, that application is going to become something that's going to last a long, long time in your environment. So the question about hardware failure is not a question of if the hardware is going to fail, but a question of when is the hardware going to fail? When is that hardware going to start causing you trouble because the hardware has such a short life cycle? So there's a growing exposure to risk. So like I mentioned before, like the applications, for example, when you first start a new application, they're going to have some bugs, they're going to have some problems, they're going to be, the risk of failure on those is going to be pretty high when they first come out. So as you go over time, there's very, very little of failure. A lot of these older operating systems and applications are very stable, they hardly crash, and they keep running very well. But then you have the hardware. So you have the hardware that was running well and running well and running well, but as time is going on in time, what's happening is that the hardware is getting riskier and riskier to run, and it's running into more and more problems. So the question becomes, how long is it safe to keep running your aging hardware? And how much is it going to cost you to keep running this hardware that has a very stable but business critical application running on it? So now we want to talk about what costs are. What are the total costs for, for running your application or your system? And basically, the cost is going to equal to three different things. One is going to be the knowledge of the staffing and of taking care of the systems and the actual maintenance of the systems themselves. The other part of what a cost would be how much is it going to cost you in terms of downtime? And the third item that we're going to look into as far as cost is going to be what is the cost of the operations of these systems in various different methods. So to start with, I'm going to start with the cost of knowledge, staffing, and maintenance. So basically, especially when you're coming to these legacy systems, because this is all dealing with legacy systems, there's no longer really programs out there teaching you how to service these systems. There used to be a lot of field engineers out there, and there used to be a lot of booklets, and a lot of people would get trained on how do I maintain these old legacy hardware servers. And there used to be a lot of people, you would even have a lot of times on site, you would have hardware engineers who knew these servers very, very well. So the other issue too is the amount of people out there that know about these servers is getting smaller and smaller. There are a lot of people that have entered the workforce and are in your IT enterprise that don't even know, what these were, have never been exposed to them, and they're like, oh, what's that box in the corner? And they really don't even have heard of something such as a VAX or an alpha. And then there's the cost of replacing parts, and that's getting more and more expensive, and the cost of those actual different parts of it, whether it be a motherboard or whether it be some kind of storage connector or network card or anything else that's part of these legacy systems. So those are some of the costs in terms of the staffing and the maintenance. So let's talk about the cost of downtime. A conservative estimate for Gartner pegs the hourly cost of downtime for around $42,000. Another Gartner study claims that most enterprise systems can face on average 87 hours of system downtime annually. And according to Forrester Research, hardware failure accounts for 31% of the unplanned downtime that will occur in your enterprise. So what this amounts to is the fact that sometimes this has the potential of costing over $1 million a year to run these legacy systems. So how much does this risk cost you? And so the question is, what do these companies all have in common? And basically what they have in common is they all experience high-profile downtime. And there was an article written up that showed that, for example, one of these companies with their downtime impacted their actual revenue of more than 20% because of the timing of when the downtime had occurred for that company. And like I said, you can read, there's a link on the bottom, and once again, we did get this information from Gartner. So this is where it says as much as 20% drop in net income in the corresponding quarter it was for one of these companies did have that situation occur. So finally, we can talk about the cost of operating these systems. So when you're talking about these old legacy systems, the cost will be the power consumption. These systems usually they needed large amounts of power, and back in the day you had these big data centers with special power coming into it. And we can also take into account the cooling of the data center as well, and the data center's floor space that these systems are taking up. Compared to modern day systems, they're taking up a huge amount of space. That's costing a lot of systems, especially if you're renting out your data center. You're going to be paying a lot of money for that data center floor place. And of course, going back to the heating and cooling and everything else, there's the carbon footprint that is associated with that whole idea of the cost of operating these legacy systems. So now we're going to talk about the next item on our agenda, which is what are your different options for these legacy systems? So we have cost versus risk. So there's the status quo, and not too far near the status quo, which is leaving things as are. You're really running at a high risk. Yes, it's not costing you anything now, but what happens if you get that unplanned downtime or anything happens? So this is very, very risky to you. So then there's spare parts. And a lot of times when I do presentations for Stromasys, I like to say that our biggest competitor is eBay, because people are going out there and they're buying the spare parts, but even those are running lower and lower out there, and there's getting less and less availability of these spare parts. And a lot of times people are even they've had multiple machines and are taking parts from one machine to look into another machine. And both these things, I'd like to say have some relatively low cost, but the risk is high. With the spare parts, you never know if they're going to run. What is going to, how good are going to be the spare parts? Can you get the spare parts? Then, of course, your other option is you can migrate the application. And migration is, a lot of people are migrating these applications, and that's very good. Now, that's going to cost probably a lot of money to rewrite, and it's also going to cost a lot of time. And this can also, in some instances, be risky, because you're running into a situation where how you know the application is going to run fine. This new rewritten code is going to run it. And as I've shown earlier, when a new application comes out, a lot of times in the beginning, it can have some issues with it. So there needs to be a lot of testing, and that can take more and more time. And, at this time, doing all that. So then what can you do? So even while you're migrating, and you're migrating this legacy app that's running your business, our virtualization is probably the best thing to do in terms of low cost and low risk. So you can run on modern infrastructure, and which can include whether it be on-prem or in cloud or whatever you have out there, and the cost is relatively low compared to the high cost that you're running as you're doing your migration. And these two can even be done in conjunction with each other. So what I'm going to talk about next is how virtualization and emulation work. So you have your at-risk legacy hardware, such as the HPs, the Suns, the Vaxes. And on top of that, you have the legacy operating system, such as, let's say, for example, Solaris. Your layered software, could it be a database or whatever layered software you had on top of that operating system that came with it. And then you have this legacy application that you have, whether it be in-house code. Sometimes the companies don't exist anymore, but you have this the software from them still running, or even, certain companies still have software out there, but that software is like 10 versions further along, but doesn't run on this legacy hardware. So what do you do with this? This is how this works, is we can get rid of that at-risk legacy hardware and replace it with any modern x86 environment, whether it be a server, hyperconverged infrastructure, a cloud such as Oracle, IBM, AWS, Microsoft. And then on top of that, you can run Linux, or we can run as bare metal, or you can have VMware. A lot of people are using VMware, and VMware is actually available in many of the clouds as well. And then what you offer is we offer a cross-platform emulator, the Karen solution. And what this solution does is it's doing dynamic it's translating the instructions from the old hardware into the modern x86 hardware. And everything on top, the operating system, your software, your applications, there is absolutely no change. This is a lift and shift of everything. It's just a dump and restore of everything from the top layer over, so that everything runs exactly the way it ran. So this is how the virtualization and emulation work, and this can usually be done in as little as less than a week in many cases per system. So what I'm going to do now is we're going to start going over some of these case studies that we had, and I'm going to turn this over to Dave.
Okay, hello everyone. Well, these case studies were chosen to, highlight what Sandy has just talked about, but also to talk about some of the things that might not show up on a ledger sheet. And of course, the case studies are folks who were very happy with, what we did for them for various reasons. WORKFLOWONE, if you don't know, is one of the largest providers of managed print and promotional marketing services in the U.S. They wanted to grow, but their data center was at 95%, almost full. They discovered they had 3 old VAXs in there, VAX 7000s, that were accounting for most of the load on their UPS. So these systems were critical. They couldn't, in continuous use, really replacing them would not really an option until they found that they could virtualize them. They virtualized this cluster. They saved power, increased space, and better hardware performance and speed. That's another benefit of something that usually these virtualized systems will run faster than they did before. The savings that they had, which you can see down there at the bottom, were actually paid for the installation, the new hardware, and the Stromasys licenses. The thing that doesn't show up on the ledger is, or as far as I know, would be something like that they did not have to expand their data center. They didn't have to go through that whole project. Next slide. Yes, thank you. Wheeler Manufacturing. Wheeler is a designs, produces, and sells wholesale jewelry. It's a family business in South Dakota. They're kind of out there in 2014, one of their drives failed. It being business critical, they were of course down, and being in South Dakota, it took a while to get a spare part up there for them. This was not acceptable, of course. So the options they had, maybe they should migrate the software. Well, that they're pretty customized. It would take a while, et cetera. And as Sandy mentioned, the no guarantee of success. And since they would like to keep using them, of course. So we went up there. We installed Share in there, and the software worked just as it did before. Again, because as you saw from the previous slide, that the migration with Sharon does not change the OS or the applications in any way. So what it does do is it makes them run twice as fast. So downtime has been eliminated up there. One of the reasons being that the virtual disks that are used in this case to hold the data, et cetera, are very portable. And so now they have backups on another machine. They have backups on thumb drives. All their data is safe that way, and they're also backing up in the cloud. So the thing that has the benefit beyond that, of course, is the owner of the Wheeler Manufacturing has a little bit more peace of mind now, and the folks don't and doesn't have to worry about losing the business. So next slide, RENESAS. For those of you who may not know, is a semiconductor manufacturing and a global supplier of microcontrollers. They have SunSpark systems in their Florida location, and as time went on, they experienced failures, hardware failures, and increasing over time. The fellow that we worked with there was not happy about his having to be called at midnight to replace parts when they could get them. Again, they have, RENESAS has proprietary and time-tested applications that they want to hold on to, and with virtualization they can. The first thing they noticed was an improvement in performance, and they've also eliminated hardware failure, and they've and now have peace of mind. Again, one of those things that may not show up on the ROI ledger, but if you're an IT admin, you understand that that's very important, that peace of mind, and not having to not getting that call at midnight. So briefly, those are our case studies. Stromasys as a company began in 1998 with the leveraged buyout of the European Porting and Migration Center in Europe when Compaq bought Digital. We started out with PDP, VAX, and Alpha, and we've moved into HP 3000, HP 9000, and the Sun Sparks, as we saw in an earlier slide. We've sold over 7,000 licenses in 50 countries. And then you can notice here at the bottom, these are our technology partners. We are growing in the industry and getting better known and getting more connections than ever, which we're, of course, very happy about. Next one. As I mentioned, these are our products here. You can take a look at these for the details. And PDP is down there at the bottom. Believe it or not, those are still around, and we do those occasionally. Our latest product, though, of course, is the Sun Spark, and we are experiencing very nice growth in that area. So it's something you might want to look into for that. And if you are a data center manager or have these one-off boxes over in the corner in a data center that you don't know what to do with it, and now you know you can do something with them and put them on an x86 box and manage them without having to pay that exorbitant maintenance cost for the old hardware, and of course without the risk of breakage. So this is our contact information. Please, give us a call if we can help you out, and we'll leave that. Are we going to leave that up there for a while, or is that part of?
Yeah, we'll come back to this slide in a second. I'm just going to go over our very last slide and mention that we can start asking questions, and then I'll take it back to the slide. Okay,
very good.
So basically, final thing we want to say is don't be a victim to aging technology. You can reduce costs, you can save energy, reduce risk, improve performance, and increase your ROI. And we're going to open this up to see if we have any questions. And that will be.
Yes, and Dave, for the first question, how immediate is the ROI?
In a lot of cases, especially if the systems were down, and we've had cases where systems have been down, the ROI is immediate. It can be just, in terms of a couple of months, definitely, if not even shorter, if the downtime is costing the business a lot of problems. In other cases, it all depends, and you have to look at it. And usually, in a typical case, it could be just a few years, but then over time, you're definitely going to get that. You're going to definitely get that ROI back.
For the second question, is the cost upfront or is it spread out?
Basically, in terms of our solution, we can do it either way. We can either have it so that you can, especially if you're doing a migration at the same time, you can spend the money annually and pay for it as you go. Or sometimes it's the difference between OPEX and CAPEX, or perhaps you want to pay for it up front and have it all up front. And we've had customers go both ways, where they've decided that, yes, we want to get rid of this old hardware and we have the funding to do that and we want to put that all up front. And we've had others who say, okay, we want to pay for this over time. So we can go either way.
The next one is about Linux and OpenVMS. The comment is, Linux, which is used for Stromasys hypervisor, require weekly based patching comparing with OpenVMS very rarely issued patching. Can you comment on virtualized system service availability and reliability when you need to patch virtualized systems weekly?
So this is Dave. Yes, I can, just a word about that. So patching the host system is an issue in the sense that, from the sense of downtime, if you have a continuously running system, of course, patches that require a reboot of the host server will, of course, mean downtime for VMS. We are hoping to have a product that has a bare metal product that does not require the host OS, but I couldn't speculate as to when that will be. But it is in development.
I'd like to also add to this as well that, you know, the host OS is just, it's not doing much. It's just being used, to host our emulator and for example, the VMS operating system. So a lot of times, once we indicate that it's not being used on a regular basis and for production, a lot of our clients, both in the Linux space and also in the Windows space, are able to decide that they don't need to be patching it on a weekly basis, and that it's not necessarily because it's not being used for anything but to host our emulator. I don't know, Dave, if you have anything more to add to that.
Yes. In fact, once the system is installed and configured, the network and access to the host OS can be, taken away. In other words, you can disable the network or any other access to the host, and sharing will not be affected. There are actually two network stacks that go on here. One is the host, one is the guest. The guest will run fine without the host. So it's really an administrative decision to patch the host. It's not a requirement.
Thank you. Next one, do you have an emulator for a legacy IBM system like AS400? If not, are you planning to have one?
Well, currently we don't, because the idea for us to create the emulator is we need the source code to do so. So that would require us to be able to get, for example, AIX source code. And at this point, we don't have access to that. We'd love to have it, and we'd love to create an emulator. But at this point, until we were able to be able to get that, we can't have an emulator to that. We do have an HP 9000 HPUX emulator coming out hopefully sometime this year.
I might also, if I may, I might also just add to that the Stromasys software is not a reverse engineering effort. It works from original specs, and so we actually need the cooperation from the company that owns the, for example, AIX. We would need to reach an agreement with IBM to do that, to provide that. So no reverse engineering here, and we okay.
Sandy, back to the HP 9000s. What kind of 9000s?
I don't have the full list of the HP 9000s running HPUX at this point off the top of my head. I would assume it's pretty much almost all the HP 9000s. But whoever asked that question, if you'll send us an email, you can send it to sales. We'll be more than happy, us.sales@stromasys.com, or give a call to the main office. Or if you're from Europe or Asia, to your appropriate sales office, we'll be able to, or go on our website, we'll be able to answer that in a little bit more detail at that point.
Thank you, and that's all the questions we have for today.
Well, in that case, thank you, everyone. We appreciate it very much. Appreciate your time.
And feel free to reach out to us with any further questions, like I said, through either our website or through the different emails available. And my email, by the way, is Sandy, S-A-N-D-Y, .Levitt, L-E-V-I-T-T, @stromasys.com if you want to reach out to me personally. And Dave, would you want to give your email as well?
Sure. I am Dave.Clements, C-L-E-M-E-N-T-S, @stromasys.com. Please let me hear from you.
Thank you, Sandy and Dave. I really want to, that concludes our webcast for today. I'd like to give a big thank you to our speakers and to those of you who are online here listening. Before we conclude, I do want to make note that our upcoming webinars and past webinars can be visited at www.ioug.org, and a recording of today's webinar will be available soon on the IOUG website in our resource center. So there's also a survey that after you close out of this webinar will pop up, and we ask that you complete that. We thank you in advance for your feedback. So again, we really appreciate everyone for attending today, and I hope you have a good rest of your day.
Thank you. Bye-bye.